You've heard these words thrown around all the time, right? AI, machine learning, deep learning. People use them like they're all the same thing, but they're really not. And honestly, that confusion can make it tough to grasp what's actually going on in our world. So in the next few minutes, we're going to clear all that up. We're going to demystify these buzzwords once and for all. Let's get into it. So, what's the deal? What is the real difference? Is it all just marketing hype, or is there something fundamental going on? The truth is, getting how these three ideas fit together, well, it's pretty much the key to unlocking this entire field. And the answer, you'll see, is way simpler than you probably think. Okay, so here's the big secret. They aren't totally separate things. The best way to think about them is like Russian nesting dolls. You've got AI, that's the biggest doll, the whole field. Then you open it up, and inside is machine learning, which is a specific part of AI. And then you open that one up, and you find deep learning, an even more specialized, powerful technique inside of machine learning. Each one fits neatly inside the other. Simple as that. So let's start with that biggest doll, artificial intelligence. This is the big dream, right? The grand goal that started decades ago, just creating machines that can think or act like humans. This covers everything: problem solving, logic, understanding language, the whole shebang. But here's the thing you gotta remember. Early AI wasn't really about learning at all. A lot of it was just programmers writing tons and tons of explicit if-then rules by hand. And oh man, this analogy it's perfect. Think about it. AI is the entire library, the building, all the books, the whole system. Machine learning, that's the smart librarian who pays attention to what you check out and then suggests the next great book you'll love. And deep learning, wow, that's the super focused researcher tucked away on a corner, literally reading every single word to find these deep, hidden connections that nobody else even knew were there. So if AI is the big destination we're trying to get to, then machine learning is the powerful engine that's actually going to get us there. It's how the machines learn. So let's pop the hood on that engine and see how it actually works. You know, for the longest time, programming was all about giving a computer very specific instructions. If this happens, do that. Super rigid. Well, machine learning comes along and just flips the whole script. Instead of feeding the computer rules, you feed it a ton of examples, just tons of data, and you let it figure out the rules for itself. It's a huge shift from being told what to do to actually learning what to do. Okay, but how does a machine actually learn, though? Turns out it's not just one thing. There's kind of like a playbook with three main strategies, and each one is perfect for a different kind of problem. All right, first up, supervised learning. The key word here is supervised. Imagine you give the machine a giant data set where every single piece of data is already labeled with the right answer. It's basically like giving a student a practice test, but you also give them the full answer key. Their job is to study both and figure out how to get from the question to the answer so they can ace the real test later. So you can boil it down to three key things. The data type, it's all labeled. The goal, to predict a specific answer. And the feedback, it's explicit. The model knows right away if it got something right or wrong, so it can learn and adjust on the fly. And believe me, you see this in action every single day. Your email spam filter is the perfect example. It learned what spam looks like by being shown millions and millions of emails that humans had already marked as either spam or not spam. Okay, next up is unsupervised learning. Now, this is where things get really interesting and a lot trickier. What happens when you don't have an answer key? With this one, you give the algorithm a massive pile of data with zero labels, and you just tell it, find something interesting. It's like dumping a huge box of Legos on the floor and saying, sort these into piles that make sense. So yeah, the playbook is totally flipped on its head here. The data is unlabeled. The goal isn't about getting the right answer. It's about finding cool, hidden patterns. And feedback? There isn't any. The machine is completely on its own to figure things out. A super common way businesses use this is for customer segmentation. A company can just dump all its customer data into one of these models, and it might automatically discover groups like, say, late-night impulse buyers or discount hunters, without anyone ever telling it to look for those categories. It's pretty cool. And that brings us to our third and final type, reinforcement learning. This one is all about learning by doing, trial and error. You have an agent, like an AI in a video game, and it just tries stuff. When it does something good, you give it a reward. When it does something bad, you give it a penalty. Over millions of tries, it teaches itself the best strategy to get the most rewards. This bike analogy just makes it so clear. Imagine trying to learn to ride a bike with supervised learning. You'd have a teacher shouting, lean left 5 degrees, pedal with 20 pounds of force. It's impossible, right? That's not how we learn. We learn through reinforcement. You get on the bike, you try to pedal, you wobble, that's a penalty. You manage to stay up for 2 seconds, that's a reward. You just keep trying until you figure it out. Okay, so we've got these 3 powerful ways machines can learn. But how do you actually build one of these things? How do you go from just an idea to a real working AI model? Well, it usually follows a pretty standard workflow. Yeah, it pretty much boils down to these 7 steps. You gotta get the data, then you gotta clean it up because real-world data is always messy. Then you do this super important split into training and testing data. You pick your algorithm, you train your model, and then comes the big moment. You evaluate it to see how well it does. If it's good enough, it's ready to go out and make predictions in the real world. And I gotta tell you, that split between training and testing data, it is everything. Just think of it like this. The model is a student. The training data is the textbook they get to study for weeks. They can memorize every page if they want. But the test data? That's the final exam, and it's been kept under lock and key. It's the only way to know if the student actually learned the concepts or if they just memorized the answers in the book. All right, so we've got the big picture of AI. We've got the ML engine that makes it all happen. But what about that tiny little nesting doll we started with? Deep learning. Let's see how all this stuff comes together in the real world, from the things you use every day to the stuff that's truly changing the future. So when do you bring out the big guns? Deep learning. Well, traditional machine learning is awesome with structured data, neat rows and columns in a spreadsheet. But deep learning, it's a whole other beast. It's designed to handle the messy, unstructured stuff of the real world. Images, audio files, raw text from the internet. Its complex brain-like structure lets it find patterns in things that could never fit into a simple table. And don't kid yourself, this stuff is already everywhere. That fraud alert you got from your bank, that's machine learning. The way Netflix just knows what movie you want to watch next, that's machine learning. Your spam filter, translation apps, all powered by these exact same ideas we've been talking about. But that stuff that feels like straight-up magic, yeah, that's usually deep learning. Unlocking your phone just by looking at it, that's deep learning. The systems that let us self-driving cars see the world, that's deep learning. Talking to Siri or Alexa, deep learning. Even incredible scientific breakthroughs like figuring out how proteins fold, that's the kind of complex problem that deep learning was built for. And that's really the point, isn't it? This isn't some far-off sci-fi future. This is here. This is now. This technology is actively shaping the world we live in today. So there you have it, the nesting dolls, the big idea of AI, the powerful engine of machine learning, and the incredible new frontier of deep learning. Hopefully the mystery is gone, but the potential, man, we are just getting started. Which really leaves us with the biggest question of all. Now that we actually know how to teach machines to learn, what's the most important thing we should teach them next?